Again, Mr. G Math, right, Jer? Yeah. Coming to you live. We're now tired. It's the end of the first session. We still have 2 hours left before the break. Just kidding. So, we still have 40 minutes before break to be able to get this going. So we're going to get this video. It's a review from what we did last week, so I know that you have the ability, right? When you have run like 8 miles, 3 miles, right? At the end, it's tiring, isn't it, to get to the end? But you just want to get to the end. Can you differentiate using the power rule? What would number 1 look like with the power rule? Done. See, that took nothing out of you. If I did a Kahoot about, like, I don't know, Family Guy or something like that, right? You guys would all light up, right? And then suddenly you would know everything about the family. Is it Family Guy? Is that what it's called? Yeah. Okay, then you wouldn't. SpongeBob. Then you would light up, right? Everything about Patrick, right? So focus that energy into calculus. Can you apply the power rule number 2? Yeah. What would it be? And get over your fear of fractions. Get over it. Negative 2/3 subtract 1. 1 is the same as 3 over 3, right? Can you quickly change 1 to a common denominator no matter what it is? Yes. What's negative 2 subtract 3? Done, right? And you can leave the answer like that. Get over your fear of fractions. Common denominators and make it happen. What's the derivative of 3? No. 0. What's the derivative of any constant? 0. I went negative 2/3 times 1, which is negative 2/3. Then I took the exponent and subtracted 1 to the exponent. And 1 is the same as 3 over 3. And negative 2 subtract 3 is negative 5 over 3. And the reason I have a video on is those July 28th, right? Those days when you have to go back to the video, right, to reteach yourself. Unless you're in some Mexican ranch and there's no Wi-Fi, then you can't review. And what's the derivative of any constant? 0. What's the derivative of any constant? Because a constant never changes over time, right? That's why it's 0. Jerry, stretch it.
So yeah, for number 2, that means it's negative 2/3 x to the power of negative 5 over 3.
Yes, that's the end answer. Do you want to have fun and write it as a fraction? Because that's fun to do. As a fraction, do you know what it would look like? It'd be negative 2 on top. On the bottom would be 3. The denominator of the fraction tells me it's the cube root of x to the 5th. Tell me that wasn't fun. But that is not necessary. As long as they're algebraically equivalent, you can let it go. But if it was a multiple choice question, right, you might have to have that skill. You're welcome. 3. In order to use the power rule, I have to write it as an exponent. The second term is not written properly. How would you write that properly as an exponent, not a fraction? 2t. Now, the number that's still in front, I'm going to write it because I almost forgot, is 1/2 still. So do you see the 1/2? It's only the variable that I focused in on. So that t cubed becomes t to the negative 3, but the 1/2 is still there in front. So the derivative of 5 is 0, and then take the exponent times the fraction. What's a negative times a negative? And what's 3 times 1/2? 3 over 2. And then what do I do with the exponent? Subtract 1. Just for fun, what would that look like as a fraction at the end? 3 would be on top. 2 would be on the bottom, and it's the, no, t to the 4th, no root, because there's no fraction. So 3 over 2 times t to the 4th. All right, try number 4. In order to write this properly, how would you write it properly? Well, 2 things. First, I would expand this. What does 2x cubed mean? 2 times 2 times 2 is 8x cubed. And then that can be written as 5 over 8 x to the negative 3. Now it's written so you can do the power rule. What's the power rule to find the derivative? What's negative 3 times that fraction? That's just negative 3 times 5, which is over 8, no big deal, and then subtract 1. Done. I'm not going to write that as a fraction right now. Now, that's applying the power rule. Again, the only time you can apply the power rule, no sleeping, right? Just resting. You know how your body is what your mind will follow, right? Put your head down like that. So you have to be able to have the skill, there you go, to write it as a exponent. Now, how many derivatives can you take? To infinity and beyond, right, Buzz Lightyear? So, first derivative, second derivative, third derivative, fourth derivative. Do you see the different ways we can write that? The first derivative has one tick mark, prime, double prime, triple prime, right? And then we just write down 4 there. And can you see the symbols for first, second, third, and fourth? Yeah. So feel comfortable with those symbols. What does it ask you to find here? The first derivative at what x value? What does it ask you to find? The second derivative at what x value? All right, let's go. So, how do I find the first derivative? I have to first write it as a exponent. Think. What would the exponent be? First of all, the big fraction in front would be 1/2. Because it's in the denominator, it's going to be a negative exponent. But it's going to be a fraction. What's the fraction? 2 over 3. All right, take the first derivative. What happens when you multiply these fractions together? Multiply. Do you see what happens to the 2's? They divide out, and what are you left with? Negative 1/3. Can you subtract 1 quickly from negative 2/3? Negative 2/3, subtract 1. Negative 5 over 3. Why can I do that quickly? Let me just make sure this is what this is. No? You never know, remember? I told you, right? Yeah. What could happen? That's an unknown phone number. That's just a tease. Where my heart can start going, is it time to go to the hospital, right? You would all pretend like there's a teacher in here, right? And you'd stay here for the whole day, and then no one would know any better. No, I don't know. I think you'd all end up at Miss Fires, because she has like 10 students or something like that. So, but it's not yet. I already told her that that girl's not coming out yet. Not. I said not till July 1st. You know what July 1st is? Canada Day. Wouldn't that be perfect? All right. So July 1st is the birthday. Okay. So how did I subtract it? Is that when you subtract 1, you need to get common denominators. So if the denominator is 3, it's 3 over 3. If the denominator was 5, it would be 5 over 5, right? If it was 8, it would be 8 over 8. Not difficult, just do it. Then, what number am I plugging in for x? 1. You're going to make this difficult, and it is not difficult. So how would I simplify it? If it was free response, that is your answer. Got it? But if it was multiple choice, could you simplify it and find the answer that matches? So, 1 to any exponent always equals 1. Again, 1 to any stinky exponent. No matter how ugly it looks. I don't care if it's 0, negative a billion, negative 1 over a trillion, negative 58 over 59. 1 to any exponent always equals 1. And 1 times negative 1/3 is? Oh, we're not done. Second derivative. How do I take the second derivative of this? How do I take the second derivative? No plugging in. So I multiply. What do I multiply together? The same power rule. Just do it again. What's a negative times a negative? Positive. Positive. When you multiply fractions, nothing divides out. Top subtract bottom. What does that mean? 1 times 5? 5. 3 times 3? 9. And then, Can you go negative 5 over 3, subtract 1? 3 over 3, right? So negative 5 subtract 3 is negative over 3. Done. Now what am I going to plug in? Negative 8. That's a fun one. Not like 1, which was super easy. Let's do it. Because you're wondering, I want to do this. First of all, we're going to do the root and then the power, and then we're going to do the fraction. All right? If this was free response, what would you do? Is there a number 3 times itself that equals 8? 2. And because it's negative, negative 2 times negative 2 times negative 2, right? So that becomes negative 2 to what exponent? Negative 8. Right? Because we did the denominator is the root, the numerator is the power. The negative exponent just means we're going to do the reciprocal. Do you know what negative 2 times negative 2 times negative 2 times negative 2 times negative 2 and so on? It's an even exponent, so it's going to be positive. 2 times 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 2. How far can you go with your 2's? 2 to the, how far can you go? 2 to the 4 is 16, 2 to the 5 is 32, 2 to the 6 is 64, 2 to the 7 is 128, 2 to the 8 is 256. Yeah, you need to know how to double numbers. Are you ever bored in summer where you just see how far you can double something? You don't ever go like 2, 4, 8, just double? Like pick a number and double it. How far can you get? Man, that's excitement. When I was a kid, that was exciting. No video games. I would pick a number and see how far I could double it. That's what we did when we were a kid. Keep doubling it. 2, then keep going. How far can you get doubling a number? See? You kids don't know what fun is, right? Back in the 70s, that's what fun was. You take a number and you see how far you could double it. So I said 200 and, so it's 5 over 9 times 200 and, but it's 1 over that, right? Because it's the negative exponent. So if I put it together, it would be 5 over 9 times 256. I don't care what that number is. But that's how you'd simplify it. That is way much fun, right? Mid-morning in June. All right, turn the page. All right, the equation of a tangent line connected to the slope of a tangent line, right? But now we're taking the point and the slope. Since the derivative of a function gives us the slope formula for a tangent line to the graph, the derivative can be used to find equations of tangent lines. Sometimes we'll want to find a line perpendicular to the tangent line. In calculus, if it's perpendicular, the word they use is normal. So when you see the word mathematically, the word normal, not psychologically, mathematically, normal is equivalent to perpendicular. Okay? So what do we know about slopes that are perpendicular? Negative reciprocal or opposite reciprocal. Come on, Jared. I know. So let's do this. Find an equation of the line tangent to this graph at the point 1, 6. To find the equation of any line, I need to know 3 things. I need to know the slope, I need to know an x value, and I need to know a y value. So start with something basic, algebra. What do I already know? Because I'm given a point, what is the x value? And what's the y value? I'm already 2/3 there. What don't I know yet is how would I find the slope? It's the derivative at what x value? So to find the slope, it's the derivative at what x value? In this case, we have f at x. So the derivative at that. How do I take the derivative of this function? What do I use? The power rule. What is the power rule? 5 times 4 is, instead of x, I'm going to plug in 1. To what exponent?
To the 4th.
Beautiful. Minus 2 times 3. And instead of x, I'm going to plug in 1 to what exponent?
1.
And then what's the derivative of 5?
0.
Beautiful. 1 to any stinky exponent always equals So this is only 20 take away 6, which is 14. Now we have what we need. So what's an equation using those numbers? Y equals, what should I write down? 14 x minus 1 plus 6. That's HK. Done. No more needed. Find an equation of the normal line at the same point. I already did the work. The only thing I need to change is what? So what would the slope be? Not negative 14. There you go. So the equation would be y equals negative 1 over 14. Same thing. X minus 1 plus 6. It's only the slope that changes. All right, let's look at non-differentiability. It's connected to continuity, right? So each of these functions has no derivative when x equals 1. Different than limit. Got it? You have limit, now it's derivative. They're connected, but not the same. So can you take the derivative at x equals 1? Why not? What does it have that doesn't? So if you have a hole at that x value, you can't take the derivative at that x value. If something's undefined, you can't find the slope exactly at that number, right? What does this have that's wrong? A jump. What does this have? What's true about the first three? If it's not continuous, you can't take the derivative, right? Each one of those is not continuous. But what's true about the next two? They are continuous, but what's wrong with them? What does this have? So at 1, it has a sharp turn. What's wrong with the sharp turn? The slope to the right is not the same as the slope to the... So you have two different slopes at the same time. No derivative. What's wrong here? This creates what type of tangent? And the slope of a vertical line is undefined. Can you see the 5 situations you cannot take the derivative of? What are they? If it's not continuous, correct? And if there's a sharp turn, sometimes we say the word cusp, or if there's a vertical tangent. So do you see that in the box here? The discontinuities compared to what's continuous. Those are the 5 situations. If a function is not continuous, it is not differentiable. A function may be continuous and still not be differentiable if it has a sharp corner or if it has a vertical tangent. Turn the page. It says, find the x values where it's not differentiable and give a reason. The absolute value of x. At what x value can you not take the derivative?
0.
Why? There, you got it. Now, every other x value you could take the derivative of, right? But that one x value, no derivative. How about 9?
Change the slope.
Where, at what x value can you not? So, if you took the derivative of what you see, the top would be 2x and the bottom would be 1. So if you plugged in 0, what would be the problem? Well, there's nothing to plug in 0 here, so the derivative is 1 and the top derivative is 0. If you would graph this, it would be continuous. But, right, when I plug in 0 on the top and 0 on the bottom, they equal the same thing. It's continuous. But what's wrong when x equals 0? What happens? Again, there's a sharp turn or there's a cusp, right? Because half of it is a line and the other half is a parabola. And where they meet, there's no derivative. Because they have two different slopes at the same time. One on the right, one on the left. 10. Again, we're going to practice all afternoon. I'm getting through this video, and then the afternoon is about practicing and getting help. Okay? When you plug in 0, what's the answer on top? And then on the bottom is, so at x equals 0, why is there no derivative? Because it is not, Jerry said it, continuous at x equals 0, right? Hey, you know these words in the box. These are not brand new words. What's number 1? What's the word that they think is new? A-Rock. Isn't that the awesome thing, right? When you get a new pet, you're going to name the pet A-Rock. Okay? Well, you got to call it A-Rock now. A-Rocky. A-Rocky. There you go. So number 1, average rate of change. Is that connected to a secant or a tangent? Is that connected to algebra or calculus? Algebra. Instantaneous rocket, right? Instantaneous rate of change. How about I-Rocky? That's the calculus. Is that secant or tangent? Tangent. Is that algebra or calculus? All right, you got it. So it says find the average rate of change. Algebra or calculus? Good. So that means this. The change, you're finding slope, right? Using 2 points. F at 30 minus F at 10 all over 30 minus 10, right? Algebra, slope, not calculus. If you plug in 30, I'll just do it for you. If you plug in 30, it's 27,060, right? Because it's 30 cubed. You could do it in your head. You know why? Because 3 times 3 times 3 is, and add 3 zeros and then add 60, right? It's not impossible to do in your head. 10 cubed plus 20 is 1,020, and that's all over what? 20. If you simplified it, that would be the average rate of change. So that means from 10 to 30, the function is increasing at that rate on average. Okay? How would you find the I-Rock? Doing the same numbers. You have to do the derivative. What's the derivative of x cubed plus 2x? 3x squared plus 2. Then what number would you plug in for 10? It's 10 only. What number would you plug in for x? 10. Did I say that weird? Sorry. What number would you plug in for x? What number would you plug in for 10? 10. For x, 10. And can you simplify that in your head? Would you get 302? Done, right? You guys are good. We're done, aren't we?